The heavy vehicle extrication kit consists of 2 10-inch hydrofusion kits, 2 extension converters, 8 12-inch by 12-inch hinge base with anchor ring, 2 36 to 50-inch Longshore strut, 2 48-inch to 73-inch Longshore strut, 2 72 to 116-inch Longshore strut, 2 6-foot extensions, 2 4-foot extensions, 2 2-foot extensions, 2 25 to 36-inch Acme Rescue strut, 2 24-inch extensions, 2 12-inch extensions, 4 48-inch pickets, cribbing kit, 4 V-bases, 4 contour bases, 6 multi-bases, 1 VSK controller, 6 tie-down keys, 2 20-foot grade 100 chains, 2 ground pads, 10 ratchet straps, 1 SBF hooligan tool, 2 chain binders, and 1 multi-force remote placement kit. We're looking at heavy vehicle versus light vehicle underride. Going to go over what we can do to help the patient out that's in the smaller vehicle with the large vehicle resting on top of the smaller vehicle. First, we're going to stop the crush so the heavy vehicle doesn't sink further into the smaller vehicle. Block out the suspension, block out the truck from rolling any further. Then we're going to start and go in with our stabilization of both vehicles. Once both vehicles are stabilized, we're going to look to lift the heavy vehicle, either extricate in place or remove the smaller vehicle from under the heavy vehicle. Okay, large vehicle versus small vehicle. The procedure we're going to use to stabilize both vehicles and attain a lift. First thing that's going to go in is the stop the crush strut. That's this strut here. It's 36 inches to 50 inches. Second thing that's going to go in is going to be your stabilization strut. Your 72 to 116 is going to attach to your chain, stabilize the tank. Next thing, we're going to stabilize the car with a 25 to 36 extension and the ratchet belt on the car. Then we'll take the ratchet straps, the tie-down keys and the cribbing so we can tie the suspension down on the car so the car does not rise when we lift the tanker. Then we're going to set up the hydrofusions so we can achieve a lift on the tanker using the 48-inch Longshore and the 10-inch hydrofusion pump base head. After all that's done and we achieve a lift on the tanker, we're going to come over, use the multi-force under the back of the car and lift the back of the car while stabilizing. Okay, first thing, I'm going to come in on the tank. I'll put the Longshore nearly vertical to stop the crush on the big vehicle over the small one. Then I'll come in with the stabilization of the big vehicle. I'm going to bring in the chain. Take the slack out of the chain. We're going to stake the base. Stake should be driven in 2/3 of the way for demo purposes. I'm just going to take them in about 6 to 8 inches. Make sure my stabilization is tight. Then connect your 2 hoses to your 2 stabilization struts. Connect the hoses to your VSK controller. Be sure to spin down the collar on the vented coupling, otherwise it will leak. Open up your cylinder, let air go to the struts. Open up your controls, just set and forget. Then, going to set up to stabilize the car. First what I'm going to do is tie the suspension down on the car, attach in the ratchet strap, attach to the top of the wheel, insert your 4x4, take out the slack, and you're going to ratchet the suspension down. What the 4x4 does, it keeps the belt off of the glass. That way the belt will not get cut by broken glass, or if the glass is intact in the back, the belt will not pressurize and break the glass unexpectedly. Now the tanker is stabilized, I can come under the tank, then we'll do the same in the front and tie the suspension down on the car so the car actually stays as low as it can to the ground. I'm going to feed some belt out. I don't need to use the cribbing on this side. Now the car is down. Now we can set up for our lift. I'm going to come in with a hydrofusion. Come in with the head. The hydrofusion we need it around about 80 degrees. That's where it's actually lifting. Then we need to stake the base. Attach the pump. Make sure the pump is open before you attach. When we do the lift using the hydrofusions, we need to go simultaneously. Line of sight is always the best. You ready? Yep. Okay, let's go. We really need another 2 firemen to work the stabilization. Okay, you're only going to lift as high as you need. Lock all your collars up. Then we're going to set up the vehicle stabilization on the back of this car. The suspension is all tied down. I'm going to come in with the Halligan tool, make the purchase, bend the metal out, then set up for my stabilization. 1 foot extension, strut and base. And bring it into the hole. Ratchet it down to attach the strap. Tighten up the strap. Okay, that's good. Car is stabilized. Then we're going to set up for the multi-force to do the lift on the car. For the person that's trapped, make sure the handle's down. Tighten up your safety collar. Make sure it's on. Connect your hose to your controls. Tighten up your safety collar. Connect your air source. Extend your handle. Slide in place. Make sure your air source is on. And you inflate. Making contact. At this time, we'll need firefighters at each of the stabilization. There, you have it. I'm Nigel Letherby with Paratech. Thank you for watching. I hope it was useful. If you want to see more, please like or subscribe.
Hello, and welcome to the next series of webinars. The webinar is put together as basically a workshop for one of the kits that we manufacture, that we've got in our catalog. So what's going to happen in the webinar is I'm going to discuss the Paratech equipment, and Andrew, who you see on the site here, will be discussing the applications for what we have for the equipment in this one kit. So again, my name is Nigel Letherby. I'm the training manager for Paratech. Andrew Hale, he's one of the instructors for Blue Collar Training Network that's out on the West Coast. But actually, Andrew is based on the East Coast. So he'll be discussing the applications that we use for some of the products that we've got that we use in this kit. Andrew, do you want to talk about Blue Collar?
Sure. Again, thank you guys for Paratech, obviously, for hosting this webinar series. And thank you for you guys allowing us to also add in some theory and practice behind street application with the kits. Again, my name's Andrew. I work in the Northern Virginia department. Just got recently promoted to lieutenant assigned to a truck company on the east end of our county, which runs pretty close to Interstate 95. So I've been fortunate enough to get on with Blue Collar Training Network as an instructor, and the guys you see pictured here, along with a few others who aren't pictured, have done a lot to, teach me that information, and we pride ourselves in going out and teaching others the information. Most of the classes we teach, we go out there and we try to, build on, Street Smart's application of tool usage, and we get out of the classes as much as we put into the classes in terms of teaching. So. Thank you guys again for having us and allowing Blue Collar to add on with some of the stuff that you guys are going to talk about today.
Thank you, Andrew. So if you take a look, I'm going to give a little bit of introduction for Paratech. We're a veteran-owned company, owned and operated. Been in business since 1962. All the product is manufactured in Frankfort, Illinois, which is just southwest of Chicago. It's made in the USA and used worldwide. We pride ourselves on the equipment that we sell, all the material we get in, and everything else we try to purchase from the United States. At the moment, we're about a 99% American company. There are just some things you cannot buy in the States. So we're focusing on that. We focus on the fire service, the military, and industrial, but mainly the fire service. We do a lot with the fire service. I'd say it's 80% of our business. The other thing, we have a full service sales support. It's coordinated through your RSMs. Depending on what part of the country you're in, it depends on what RSM you deal with for Paratech, and they can get you anywhere from a small tool up to a trailer. They can help you out with that. So the workshop navigation will be either on the bottom of the screen or on the right-hand side of your screen. There you can ask questions. You can type in the question. We'll answer them, or a team of us will answer them with being our RSMs. Plus, throughout the workshop, we will be doing a question and answer segment that involves us talking live and answering the questions live instead of on the actual keyboard. And we'll be doing a question and answer at the end of the workshop. This PowerPoint presentation is for informational purposes only. It's not a substitute for hands-on training taught by a qualified instructor. Regular hands-on training is necessary to become proficient. Improper use of any equipment may cause serious injury or death. Think safe, act safe, be safe. Remember, always lift an inch and support an inch. So the workshop we're doing today is covering the heavy vehicle extrication kit. As you see, there's a wide variety of equipment there, going from our gold Longshores to our gray Acme Strut, to high diffusions, to the multi-force, to a cribbing kit, and there's even a couple of pickets in there. So with the Longshores, this is the equipment that's in the kit that we can use. It's 2 304 Longshore struts, 2 406 Longshore struts, 2 610 Longshore struts, 2 24-inch extensions, 2 48-inch extensions, 2 635 6-foot extensions that will allow, when you put it onto the back of a 610, it'll take you to 16 feet. We got 2 high diffusion 10 kits, 2 extension converters, 6 hinge bases with anchoring, 4 V bases, 4 contour bases, 4 multi-base, and 2 non-slip neoprene pads. The other thing that's within this kit, we've got a kit within a kit. So we've also got a rapid extrication kit in this particular kit. And the rapid extrication kit involves the Acme thread struts and the multi-force. So we've got a couple of the 25 to 36-inch Acme thread struts. We got 2 1-foot extensions, 2 2-foot extensions, 2-inch base with anchoring, 4 ratchet belts, 2 tie-down keys. We got a multi-force remote placement kit. We got 4 double-headed pickets. We got 2 grade 100 chains. We've got a couple more ratchet belts, a couple more tie-down keys, 2 chain binders that we use with a chain, 1 VSK controller, 1 cribbing kit, 1 SPF hooligan tool. And if you take a look at that kit should give you everything that we need to do to cover from light vehicle stabilization up to heavy stabilization and lifting. So we're going to take a look at the Acme thread struts. In this kit, there are 2 25 to 36-inch Acme thread strut. You take a look at the picture on the left. You'll see the gold collar, and you'll see the label. The label is just going to give you what capacity that strut will go to, with and without extensions. The collar, the light gold collar, is where the Acme thread shaft comes out with the tube. As it is in that position, that collar is the top of the strut. However, that strut can be used in any orientation. If the label was on the upside down, basically, then the solid end where the air chuck is will be your top. does not take away any of the capacity. If you take a look, the maximum load for an Acme thread strut up to 4 feet is 80,000 pound 1-to-1. We operate on a 4-to-1 safety factor, so your workload is going to be 20,000 pound. But if you take a closer look at the label, on that label itself, we've got a 4-to-1 and a 2-to-1 figure. So if, for example, you're operating and you need a little bit more capacity, you could drop down to a 3-to-1 or a 2-to-1, and it gives you that capacity. You're just losing that margin of safety. We do a maximum of 2 extensions, not to exceed 3 feet on an Acme strut. We've got a 1-2-3 rule with the Acme strut. 1 strut, 2 extensions, not to go over 3 feet. On these struts, it's got pneumatic fittings on there, in case you need to use them in a trench rescue application. They are designed for spanning shorter distances. Okay, some of the bases we've got. If you take a look on the left, we've got the multi-base. The multi-base fits on both the gold Longshores and the gray Acme thread struts. It's got a 90-degree V in the top. It's got a slot that accepts a 3/8 chain. It's got 2 45-degree angles that you see there. It's got 2 points for locating in holes and maybe in the fender. It's got a 1 lock pin. It's got a 3/4 hole that goes all the way through the center of that head or base. That accepts a web shackle, just in case you use synthetic slings. The hinge base plate is a 12x12 plate. It's got a large footprint. It's got 8 picket holes, 4 on each side. 45-degree clevis that goes both ways on the plate. It's got nail holes. It's got 2 nail holes in case you want to put it to 6x6 or 2x10 in the trench or whatever you need to do to nail it in place to keep it there. It's got 2 concrete anchor holes that you see each side of the nuts. And it's got a 5,000 pound anchoring with a 4-to-1 safety. It's got a diamond grip surface on the bottom for non-slip, a lock pin, and a carrying handle. Carrying handle is actually in the actual dark gray part of the base. That is not rated. It's not used to hook a chain or hook a ratchet belt onto. The other bases or heads we have are we've got extension converters that we can use on extensions to make a rigid stabilization platform. They can also be used in the hydrofusions that we may be talking about a little bit later. But if you take a look on this extension converter, it's got the base end and the hydrofusion end. That long piece that goes up to the shoulder, that's the only piece that goes into the hydrofusion. If you try to put the base end in, it gets jammed and it's going to come back to the factory to be repaired. The other thing, we've got a contour base. Contour base has got those stipples on there that grips onto the frame and even A-post, B-post on the car. Then we got the V-base. The V-base is just a 90-degree V. It's got 2 45s on there that goes into your channels on the underside of a vehicle, underside of a car. Also got nail holes in there. Nail holes are there as if we can use this in maybe a structural collapse application or even in a car application where we got a piece of 4x4 up against a curb and we put a couple of nails in that base that sticks to the 4x4. So then the 4x4 gives you low displacement when you're stabilizing whatever you need to stabilize. The 27-foot ratchet belt with fingers. It's got a rating. It's got a rating of 3,300 pound. That's with a 3-to-1 safety. It's got a 10,000 pound braking. It's got a 12-inch static end. As you see, the 27-foot moving end. It's got an ABS release mechanism. Excuse me. If you take a look at the right-hand picture, you'll see those gears. It's a double gear system there. You see there's a lead pin at the bottom. Once you take the handle over that lead pin, you can actually ratchet that belt down, not up. Releases tension on your stabilization. So if anything does happen with load shift or you're taking something apart, it's not going to come down around your feet. You can actually release it nice and slow, so the force has gone off your ratchet belt, so you can actually take things apart. The other thing we got these tie-down keys or Tolman's keys. It's got a large foundry hook. It's got a small J. It's got a T key. It's got a grab hook for 3/8 chain. It's got a large center oval king link. That's what you need to put your finger hooks into. It's rated for 5,400 pound. As you see, it's got a tag right up close to the foundry hook. And on there, it tells you all about that, what that cluster is rated for. So all parts of that cluster will be rated for 5,400 pound. On the right, we got a 20-foot grade 100 chain with grab hooks on each end. The grade 100 is rated for 8,800 pound, 4 metric tons. It's got a safety factor of 5-to-1. And it's got an informational tag that's by one of the hooks. An informational tag is important on chain because anywhere from grade 80 up is rated for overhead lifting. And a lot of times if we're using chain with vehicles, especially with heavy vehicles, we are actually doing an overhead lift with that vehicle. So we need to know that our chain is strong enough to do what we need to do with it. Okay, Andrew, over to you for this part of the workshop.
Very cool. So now we're going to take that kit and kind of apply it to the real life scenarios. The way we spin a lot of these scenarios is when we're looking at, and right now we're going to talk about passenger vehicles, but when we look at passenger vehicles, we try to train for the 3 common ways we may find a vehicle: vehicle on all fours, vehicle on its side, or vehicle resting on its roof. For these, because we're applying the struts and the extensions, the gray series, into the passenger vehicle, we're going to focus more so on the vehicle on its side and the vehicle on its roof. So initially, the way we train and the way we operate, initially the way my department runs is we have 2 people that are riding behind us in the back. So whenever we're running into these scenarios, we want to size up, make sure we're applying the right principles to the application on the street, and we do our initial stabilization. When we're talking about the vehicles in the coming slides, when I refer to the clean side of the vehicle, I'm talking about the side that the passenger may be sitting on, whereas the dirty side is where the tires and underside of that car is. So when we're talking about those 2 components, I just wanted to kind of highlight that so we're all on the same page. When we set up our stabilization and prior to extricating a patient out of the vehicle, the way that we want to set that the stabilization up is to make sure that we're focusing on our plan for extrication, so our stabilization equipment does not get in the way. So when we're looking at these scenarios, our setups are going to be with the idea that the less equipment that's in the way of our operating area as we extricate is going to be more beneficial to our cleaner working area. Looking at the vehicle, when we first look at the vehicle on its side, we're going to look at how the same side tieback provides for a clean work area. Also, we're going to talk a little bit about determining strut lengths. The way that I really like with these gray series in the kits and the way that everything is sold, if you take that 2536, have that 12-inch base or 12-inch extension connected first to the strut, and then the 24-inch extension connected on the bottom side. If we determine that we need to do a lift, that 24 extension is just about the same side as the 10 HFS. So that HFS 10 is about 25 inches long. So if I determine I need to do a lift, I can easily remove that 24-inch extension, slide that HFS up in there, and now we're rocking and rolling instead of having to disassemble everything and then reassemble things, just depending on how we set up. So the things that we have riding in the rigs, we should also be planning for using on the street, and ease of operations is always key. Like I said, we'll take that 25 to 36-inch strut. The next part down on the bottom side of that strut will be the 12-inch extension, and then the next part will be that 24-inch extension. We unfortunately can't ride with our bases connected, so that 12-inch hinge base isn't connected. But that's just something that we have to play with, getting on the rig or getting on the street and putting those together. And we'll talk about that here shortly. Tieback options. There's multiple things that we can utilize to tieback, like Nigel kind of talked about earlier with that ratchet strap, the 27-inch or 27-foot ratchet strap. My apologies. That provides a really good opportunity for tieback instead of having to pull and unspool the winch, or also pull a grip puller out if that's the case. So we'll talk about the spanning. And then even after we stabilize, we want to make sure that we're continuously evaluating how that stabilization is in the setup. So as we start to disentangle the patient or remove components of the vehicle, you really want to make sure that that stabilization equipment is still actively stabilizing the car instead of becoming loose and nothing has changed. Especially with doing the same side of posing, if everything's being operated on the clean side as we start to extricate and all of our stabilization is on the dirty side, a lot of times we don't have eyes on that dirty side. So that's where, as an OIC or an officer, on the unit, I'm making sure my driver's going around to that other side and looking at those things. We can go to the next slide and we'll start talking about some of the components. So here you have, we have two vehicles, left side picture, right side picture, resting on their sides. So you can see in both scenarios, we have that gray series strut attached to the vehicle on the dirty side of the car. So the way that we operate this, we'll roll up onto this. One of my people in the back are initially stabilizing that vehicle. So with that cribbing kit that Nigel talked about earlier, if that's an option for you guys or you guys are using wood, initially stabilizing that vehicle is key. The one thing with these vehicles on its side, especially if that driver portion of the vehicle is suspended up in the air and not low to the ground, is your center of gravity is a little bit off. So what we want to make sure of is that that vehicle is initially stabilized so we don't have any move, or we kind of control the movement prior to putting our finishing stabilization in place. So with that initial stabilization, we're throwing wedges on either side. I also like taking a step chalk, inverting it, and putting it underneath the B post on the clean side of the vehicle. At that point, we're getting eyes on the inside of the vehicle, and I'm also going around and doing a larger 360. Chances are, if the vehicle has rolled over and landed on its side, there's either an object that stopped it, or it just came to rest there after rolling a couple times. So your outer circle is going to be a lot larger in these situations. Once that initial stabilization is done and we've done our size up, you can see that the two gray series struts are in play. Now, the thing that I like about these gray series struts is you can leave them pre-assembled if your rig is spec to your equipment. But like I said, that 25-36, the 12-inch extension, and the 24 is going to be key every time. Vehicles are about 6 feet wide, so that initially that size strut length is going to, and extension length is going to give you a pretty good size to get that strut into play. So when you're setting this up, again, you can see the components. We have the multi-base up at the top, the three components I talked about with the strut, the two extensions, and then the 12-inch hinged base on the bottom side. What I like to do when we approach that vehicle, usually if you stand with your arm length out to that car, so imagine my side of the screen here is that car, and I stand arm length out, where your feet are down at the ground, that's usually where that base is going to be put. Once you put that base down on the ground, you can then extend that strut out to make your connection, whether it's on a pinch weld, whether it's on a structural channel on the bottom side, wherever that case may be. Get that thing into place, make sure it's locked down, it's in there snug. And then what you want to do is get those ratchet straps to the bottom with those toe keys. And you can either go from base to directly with the ratchet strap to the car, or you can run it kind of like a V channel like we do, or a V pattern like we do here, or on the left side picture. So in that, what you really want to make sure with these struts, and it's understanding principles and talking about how everything's being distributed. We're not necessarily trying to, we're not dealing with a ton of weight here because the majority of it's resting on the ground. What we're trying to do is stabilize the vehicle so it doesn't move while we start to extricate. So remember, these Paratech struts, they're designed in compression, but to put them into compression and make sure that they're being loaded correctly, you want the tension of that ratchet strap at the bottom. So just enough to get that strut under compression, make sure that tension's good. Now, if we're looking at that before putting that tie back in, the only thing that we're preventing that vehicle from doing is moving towards that dirty side or pivoting towards that dirty side. We also have to prevent it from rolling towards the clean side. So that's where the tie back comes into play. That 20-foot chain, which is really good in these scenarios, you can wrap it around each axle and bring it back. And now I can tension it back to an object or a rig if it's there, and that rig isn't going to move. So like you see here on the right-hand side, so the left-hand side, that's a training scenario we set up. We just kind of rolled in there, dealt with the vehicle resting on its side. did same side opposing, and then tensioned it back to a guardrail that's on our training pad. On the right-hand side, what you see is same idea. So we've done it enough in training to where we rolled over to this car here on the street. We did same side opposing, and we had a tree that was lined up right with that dirty side. So we were able to take a ratchet strap and tie into that tree for our connection point. Trees are really good. Guardrails are really good. If a light post seems like it's structured, I mean, we've even run vehicles on its side where we tied back into another vehicle that was damaged in the accident. So just be really mindful of that. Again, what you want to do with that, when you make that connection, that tie back is just preventing that vehicle from rolling towards the clean side. So we're not looking to put a ton of force on there. We're putting maybe a couple 100 pounds of force onto that. It's nothing too crazy. But when we're tying that back, all we're doing is preventing it from rolling to the clean side. So now you see it's prevented from moving to the dirty and prevented from moving to the clean, making it stable and allowing us to get in there and extricate. So those are two ways that we can, set this up for street application. Here's another scenario. So sometimes you don't have the option of utilizing same side opposing. So you can see in this scenario, this vehicle is kind of resting a little bit outside of where that common ground is on the with the angle being pretty close perpendicular to the ground. So in this case, what you see is we have two struts set up on the dirty side, or on the clean side, my apologies, and one set up on the dirty side. So really what we're looking to do here is take the applications that we know that these struts can exist in, the physics and everything understanding, and applying them to how the vehicle is set up. So we spent a lot of time drilling on these three orientations the vehicle can be, kind of relayed in. But when we're looking at this is a little bit of a unique setup, because now we're dealing with something that if those struts aren't in place or we don't initially stop that movement, it could potentially continue to roll onto that clean side. So rolling in or coming into the call, the one thing that we're looking at is making sure we stop that initial movement. So we prioritize putting two struts here on the clean side and one on the dirty side, making it very stout, preventing movement from either side. There's absolutely nothing wrong with doing two on the dirty side and one on the clean side. In fact, the one on the clean side, again, is going to leave equipment out of the way to make sure that it's not in the way as we start to extricate, because you have to have a little bit more finesse to make sure that those tools aren't going to rotate or move into those struts that are stabilizing the vehicle. Now, in these pictures, you can see, again, the gray series strut tied in with the ratchet strap and the toe clusters that are being connected towards the bottom A pillar and the bottom C pillar on the clean side. On the back side, again, on the dirty side, we're just looking at the V pattern there and the ratcheting component or the ratchet strap running through that base handle on the 12-inch base handle, and two clusters that are tying that into that dirty side. So just a different orientation that we may have to apply depending on which way that vehicle has potential to move. Now, the roof resting option, again, if this is one of the three components that you may find that the vehicle may be resting in. If it's resting on its roof, chances are it's probably rolled a few times and landed on its roof. Now, the roof, with everything intact on the vehicle, we're talking glass, the pillar's not damaged, that roof can hold a substantial amount of weight. The downside is we don't want to rely necessarily on that weight of the vehicle, because we may have to remove the roof to get to the patient. So what you can see here is we did a tension buttress to tie that vehicle in, stabilize that vehicle. These struts are set from anywhere from a 45 to a 60 degree angle. And you can see that, again, we get out, tie them up, and then we can operate with how we need to operate. So the one thing that we've played around with, and like I said earlier, there's a couple ways that you can approach this. Lifting, if you understand the principles of the lift and the dynamics of the movement, you can apply different lifts into different areas. With the potential of the rollover and the glass breaking with the rollover and the movement of the patient within that vehicle, if they're not wearing a seatbelt. In these scenarios, whether it's a vehicle resting on its side or a vehicle resting on its roof, there's potential for a portion of that patient to be either ejected out of the vehicle or hanging out of a, arm hanging out, leg hanging out of the sunroof, side window, whatever the case may be. So because we set our struts up with that 2536 strut, the 12-inch extension, and then the 24-inch extension, we may roll out and initially put the tension buttress into play without those HFSs to get it initially stabilized. So one of the things that we've talked about, and I mentioned it earlier, and you can see with the two pictures. So the picture right now on the top left-hand side, we rolled out, we set our Gray Series struts into place, and we captured that vehicle that was resting on its roof. Well, then we started discussing, well, what if we need to do a lift? And we were, too quick or we didn't even initially realize that there was an ejected part of the patient. What if we needed to do a lift here? This is one of the cases where I would be 100% okay doing a single point lift, as long as you had a good capture point with the strut base in connection with the vehicle, and you had it stabilized with the struts on either side. So in this case here, what you see on that, again, with that top left-hand picture, tension buttress. So we have our struts into play. We have chain around that trunk side of the vehicle. And then that ratchet strap that you see is preventing that chain from kicking out towards the back end of that vehicle. Once those are into place, then we put our ratchet strap on the bottom side, again, bringing that tension into with the bases, allowing that the struts to go under compression, essentially stabilizing the load. Well, once that was into place and we were like, we started playing around a little bit. We were like, well, what do we need to do if we need to lift and we want to lift on the backside? What should we do? So we threw another one of our struts into play with the HFS 10 and started doing our lift this way. And you can also see, which we're going to talk about further in the webinar, is that we have a VSK hooked up to those struts to, as we lift, now we can also capture and stabilize continuously at the same time. So, we're real big on having multiple plans, because plan A may not work. We try to plan for A, B, C, and D all the way down until, either we run out of equipment or a wrecker operator gets on scene. Now, if you do know that the lift is coming up and you do a good size up and that lift, we know that we need to do a lift. Somebody tells us on scene, hey, we got a plan for this lift. You can set up the operation the same way. Now, if you look on that picture on the right-hand side, we took those 24-inch extensions off. And again, like I said, that 24-inch extension and the HFS 10 is about the same size. You got 1 extra inch on that HFS 10. But if you just slip off that 24-inch extension, hook up the HFS to the strut, the 2536 with the 12-inch onto the strut, and you put them on either side, everything else is the same. So we operate with the tension buttress. We wrap the chain around the trunk, put the struts into play in that chain, tension that chain back towards to prevent that chain from slipping out towards the back end. So we tension it around the front side of the back tire axle. And then we put that ratchet strap into play to tension putting those struts under compression, and then also allowing for the system to be, take all the slack out of the system. Once that's set up, now we can lift from either side, and we're doing the lift and capture them with the gold collars as we go. So you can even set up, if we go back to looking at the picture on the left top hand side, you could set up with your stabilization initially on the backhand side, just like you would a vehicle on its roof, and you could put airbags in the front. So that's another viable lift that, if you need to do that, now you're pivoting off the back. You just have to be very mindful of where those movements are in the system and make sure that stabilization, all the slack is out of that stabilization component of the vehicle, and everything is good to go with that lift, and everything's being monitored from all 4 sides. But again, just multiple ways to lift. And like Nigel said earlier in the video, we can look at these all day long, but these are one of those things that you have to get your hands on. You have to apply with the kits that you guys have or the equipment that you guys have. That's going to be best case, in these scenarios. The good thing about these webinars is it kind of exposes ideas to, street application and kit application. But hands-on, this stuff is always going to be, always going to bring that street application into fruition. So. Here we have, I was fortunate enough to take a RecMaster level 2-3 class. And one of the things they showed was, and everything kind of focused in that class on the rollback. So, a rollback operator comes on scene and they decide that, they see the vehicle on its roof, nobody's in there, they got out, whatever the case was, but they need to recover this vehicle to take it to the tow lot. So one of the things that they talked about in that class was the ability to flip the car to get it to land on all fours and then essentially, haul it up there with their winch line onto the rollback. So from that class, we came back and we were like, well, I wonder if we can play with this a little bit to kind of make it so we can even lift one side of the vehicle up with the same principle. So here you can see the Gray Series strut, and the way that this strut is set up, and you can see it. So the strut up on the left-hand side, you have the Gray Series strut going into the vehicle on the pivot side that we want, not on the side that we want lifted, but into the pivot side. We have chain wrapped from the side that we want to lift up into the strut, and then we have another one foot chain extension or chain bridle that we have to connect our grip puller into. So essentially what we do is, and if you look on the top right-hand side, if you start tensioning back towards where that strut is, you can actually pivot and lift that vehicle up. So say you get into a scenario where you can't facilitate getting the struts into play to facilitate a lift, but you need to get a lift up to get that patient out of the vehicle. This application can be set up to move that car from this orientation and just pivot it up a little bit. The big thing to be mindful of here, though, is you want to make sure that you're obviously not pivoting off of a component that's damaged or pivoting off of a patient that's in that vehicle. So again, just talking about the setup with that strut, that Gray Series, that the base, the 12-inch base is tied into the bottom. You can also use a multi-head in there to get a little bit better of a bite. But again, just make sure that base is connected to that dirty side of the car. The chain is wrapped from the side that we want lifted to make connection into the multi-base head at our base at the top, tied completely to the vehicle. And then we're tensioning that strut back. So as we start to pull, it's actually lifting up like you see on the right-hand side, exposing area for us to get in there. Now we can throw in more struts on the side that we lifted, capture that lift or capture that movement that we had in the vehicle and get in there and extricate as needed. So, there's a lot of, if you understand the principles with these struts and the principles of a lot of these movements, there's a lot of different applications that you can put these components into. So that's just another way to facilitate a lift when you don't have the room to necessarily get in there with the tension buttress, set up a cradle and lift that way. Here we ran into, and this is really where I think Paratech sells when we talk about the products that Paratech puts out. It's the versatility that all these pieces of equipment can be utilized in. So we know that the Gray and the Gold series, we can use them in vehicle application, we can use them in trench, we can use them in structural collapse. There's a lot of things that we can utilize these, or a lot of scenarios that we can utilize this equipment with. So here we were presented with a call where a patient went through the bottom side of a split foyer home. So split foyer, obviously doors in the middle. You walk into a landing and you can go up or down. Well, this patient kind of went off the road and down into the basement level of the home. So we had to, it was kind of multifaceted here because that the backside of that car is still hanging up by the foundation of the house. The inside of the vehicle is pivoted up a little bit to where it's hanging off the ground. So we had to attack this in multiple angles, which is where when you get a kit like this, where you have multiple options with multiple struts, multiple configurations, you can put a lot of things into play, especially if they're all on your front out piece. So when we rolled into this scenario, initially what I did as the driver operator that day, tied that vehicle back to prevent it from wanting to kick in anymore to the vehicle or into the house. So you can see the lights are still onto the vehicle, the passenger's still in the vehicle. So initially what we did was we tied it in. The next thing I'm looking at is I'm making sure, my crew has everything they need on the inside. They wound up using step chocks and cribbing on the inside because I wound up using the Gray Series struts that we carry on our front out truck as also for stabilization of the structure itself. So we carry the HVEK, the kit there, the heavy vehicle kit. It doesn't have this, but you have the option to add these in. But we have a 6-inch swivel bases that we can connect as well. So we're able to tie into that house, make sure the house, we were giving it support along with extricating as needed. And you can see this was the picture on the right-hand side is after the car was removed and the patient was extricated. We wound up having to do some shoring on the inside so the homeowners can get in there and it was safe for them. But again, the versatility of this equipment is huge. So we were, even though this was a vehicle scenario, it also wound up being a structural collapse type scenario. We were able to apply the Gray Series struts into play along with stabilizing the vehicle with the equipment from Paratech and making sure that that patient got out in a expedited manner to get the medical help they needed.
Thank you, Andrew. Okay, now I'm going to talk about the Longshore struts and extensions. The Longshore struts were designed for PEX low capacities. They were designed for a longer throw of shore at a good capacity, at the same capacity. So if you take a look, they were designed to maintain the low capacities and the safety factor while spanning long distances. Maximum of one extension per strut. The picture on the left shows you the two 304s, the two 406s, and the two 610s. And the picture on the right gives you the two extensions. We also carry a 2-foot extension in this kit. That's a 4-foot and a 6-foot extension. Maximum workload, 1-to-1 on the Longshores is 80,000 pounds at 8 feet. Again, what I was saying, we go back, we're a 4-to-1 safety company. So we give a 20,000 pound workload with a 4-to-1 safety factor. Again, the labels on the Longshores give you 4-to-1 and a 2-to-1. So if you're at the 4-to-1 and you lose the extra couple of thousand pounds, you could drop it to a 2-to-1. Take a look what the figures tell you, or a 3-to-1, and go with the same shore. The Longshores also have the pneumatic fit-in on the bottom. That's there for if we want to use a controller to follow the load, to chase the load as we are lifting. Also, we use Longshores in trench rescue. It's there if we want to use the controller in structural collapse. But on this kit, we mainly use it for chasing the load as we lift a heavier load. These struts were designed to do the heavier vehicles, your semis, your buses, to your cement mixers, even trains. Again, they were designed for spanning longer distances with keeping the same workload and the safety factor. Going back to what I was saying about a controller, this is the VSK controller. It operates anywhere from 140 to 200 PSI. That is your actual inlet pressure with our single coupling that's on the left. The two couplings on the right are your outlet couplings, which it reduces that pressure down to 25 PSI for your outlets. So it's not going to be enough to push the load over, especially when we deal with heavy vehicles. It's got vented couplings on there. It's the new safety couplings. Whereas if you've used airbags, excuse me, if you used airbags in the past and you're taking everything apart, you always take the coupling off and you get that loud air sound where there's air in the system. That's what the vented couplings prevent. You've got to adjust that coupling up to the collar for it to work, and it's got to be adjusted all the way back down to the nut for it to disengage. That's going to vent what you need to vent. It's got a quarter-turn positive knob on the top, and it's got a protected relief valve that's in the body itself. It's a great tool, especially if we lift in heavy vehicles off of lighter vehicles, and we need to chase the load. Other things in this kit are we got a ratchet binder. Some of you may not have used a ratchet binder. Basically what it is, it's two grab hooks that hook onto a chain that tightens the chain up. That's all it is. This one's got a 9,200 pound rating. We use this with our grade 100 chain. It's got an 8,800 pound rating. So the ratings are all there. It's a great tool, but if you've never used one, you could get a little bit stuck. And going back to, that's what training is all about. The other thing that's in this kit, if you take a look on the right, we've got the plastic cribbing. It's the interlock cribbing with step chocks, wheel wedges and everything else. That comes in the kit also. If your vehicle is rolled or whatever that Andrew was saying earlier, where you may need just a 4x4 with a wedge, that we've got. So all within the kit. Okay, Andrew, back to you to discuss the chain attachments.
So we're going to get a little bit into this as we move forward in the presentation, but the chain attachments are real, it's a very important aspect to think about. So when we start to talk about heavier loads, what's regulated on the street allowed is up to 80,000 pounds. So when we talk 80,000 pounds, I mean, that's a ton of force. So like I said, further in the discussion, we're going to talk about axial forces and horizontal forces placed on that strut and on the components that are attached to the strut. The one thing that we've moved away from, and as Nigel talked about earlier, what we don't want to do is necessarily use tie back, like the clusters, the tow hooks, or ratchet straps with these bases when we make those connections in heavy vehicle operation. So as you can see here, one of the things that we utilize, and Nigel, correct me if I'm wrong, Paratech may also sell these. It's not in the heavy vehicle extrication kit, but it is something that is offered, I believe. We sat down with them we were at a class a couple of years ago, and guys way smarter than me sat down. They were like, what can we make to kind of make sure that we're making the right attachment points? So one of the things that the group collectively came up with, you can see on the left-hand side, we have a chain bridle, again, rated for grade 100. It has a foundry hook, 2 cradled grab hooks, and then also a sling hook on the bottom side. So when we start to make our chain attachments and we're attaching those bases to the bottom, we really want to make sure those horizontal forces that are being calculated are able to withhold, the equipment's able to withhold those forces that are being exerted down on that equipment. So what you can see here is on the right-hand side, we have two of those bridles connected in, sling hook on either one of the handles, the swivel handles on the 12-inch bases. And again, that's preventing that horizontal movement and calculated for those forces when we start to do these heavy vehicle operations. Really good piece of equipment. Again, we want to stay away from those, the toe keys and the ratchet straps. Those are meant for static tie downs when hauling loads back and forth across the road. When we talk about doing heavy vehicle extrication and heavy vehicle lifting and moving and all these things, accounting for those loads, we want to make sure that the system is set up with loads that can handle those, or equipment that can handle those forces. This again is just another option that you can utilize to handle those horizontal forces in terms of application. Now, I think one of the things that I really like about this kit that and Paratech has offered for the last couple of years is this VSK. Prior to the VSK being an option for a lot of us on the street, what we would have to do is either chase that lift with cribbing, which can be a little bit of a pain if we're dealing with a heavy vehicle over top of a passenger vehicle just because of the height, or we would have to push up the strut or push up the strut extension and lock that collar off, and it was always going back and forth. So when Paratech created this VSK, what it does now is it offers us the ability to continuously have contact between those capture or the capture struts. So as we lift, that VSK now is offering positive connection to that object that we're lifting, and all we have to do is lock those collars. So it's a phenomenal piece of equipment. You can see here we're doing on the bottom side with a larger overview of that picture. We have a override, so larger trash vehicle drove over top a passenger vehicle, and we're doing that lift to extricate the passenger vehicle out from underneath of that larger vehicle. So when we do the HFS lift, again, you have to be mindful of locking those collars as we go and lift up. But the VSK, again, it just gives that positive capture to make sure that as we're going up, we know that we're in contact. If those collars on the capture side are being locked off, and the collars on the gold or the HFS is being locked off, we know that we have positive capture throughout that whole thing. So if we need to do a reset in the system, or God forbid something maybe a valve leaks or something goes wrong in the system, something shifts, we know we have that capture that we need be. The other thing about these, and we'll talk about whether, capturing and stabilize or lifting and capturing from the underside of the vehicle or lifting and capturing from the outside of the vehicle is more beneficial a little bit later in the webinar. But the thing about, people are always concerned about being underneath of these heavier vehicles. Well, there's a couple things that are playing in our, in our advantage here in that case. One, depending on how that larger vehicle is set on top of that smaller vehicle, that larger vehicle, as long as there's no shifting or continual shifting, that larger vehicle shouldn't move until we start exerting forces on it. The other thing, so that space that's there underneath, it's not going to go down any further. It may shift depending on what starts happening prior to us getting hands on the vehicle, but it shouldn't go down any further. So setting up, we're going to, and we'll talk, like I said, we'll talk about this further on the webinar, but setting up your equipment on the underside of that heavier vehicle isn't a bad option at all. If people are concerned with getting underneath that vehicle, one of the things you can do is with that 27-foot long ratchet strap, just the strap end of it, you can actually wrap that around the collar. So now you can position yourself like these two crew members are on the outside from underneath of that vehicle. And as that lift and that capture strut is extending, you can then rotate that ratchet strap locking that collar up as we go. And again, it's just a game of give and take. So you're just locking it down and moving that ratchet strap around the collar. That 25 PSI, like Nigel said, isn't enough to lift the vehicle, but it's just enough to give us that positive capture as long as that collar is being locked off. So it's giving us that positive connection to the larger vehicle or the vehicle that we're lifting in order to make sure we have continual contact without the struts or the capture struts being, moved or shifted out of play. So now we're going to, like I said earlier, now we're going to start talking about that heavy vehicle rescue application. So the good thing about this heavy vehicle, kit is it allows for a lot of components to essentially effectively operate and get this passenger out of the vehicle. So what you see here is there's multiple types of accidents. You can have passenger versus commercial vehicles or commercial versus commercial. The big thing, again, with all these is you want to make sure you do a thorough size up. Like in this picture here, this call happened at 2 or 3 o'clock in the morning. Unfortunately, the patient fell asleep at the wheel and drove into the back end of this tractor trailer, essentially, being underneath of it a little bit. So we had to facilitate a lift. So when we're doing that, there's a lot of things that we need to, keep in mind. What is the true weight of the vehicle we're dealing with, right? Has the vehicle just started their day, or the commercial vehicle just started their delivery day, or are they towards the end going back to the lot to store the truck for the night? Did they just go through a truck scale? Is there something there that, they can give us a ticket that says, hey, this is how much this weighed at the truck scale just a mile down the road? Other hazards to think about: fuel leaks. What are they carrying in the trailer, or what are they carrying as a load? Has the load shifted? I mean, these tractor trailers, the weight is designed when we're talking about moving loads or transporting loads up and down the road. The bottom side of that trailer is what's designed to carry that load. Once those walls or sides of that or front or back of that trailer starts experiencing any load, it's not structurally designed for that. So that's another case where those longer Gold Series struts can be put into play. Just like you build a raker for structural collapse, you can build a raker up to the side of a trailer and make sure that box is now essentially stabilized to make sure as we start to move this larger vehicle, that load doesn't shift any further. The one thing you want to make sure, though, with these is we don't start opening components of that trailer, right? Because especially in a case like this where that trailer is involved in the wreck pretty good, we start opening those back doors and trying to get a feel for what's going on inside. We're starting to ruin that integrity that may already be ruined from that accident. So when we're looking at these, again, we're going to control movement in 6 directions. So when I say control movement in 6 directions, and this will play with initial stabilization all the way to, our final stabilization into our lift into, pulling that passenger vehicle out, is you want to make sure we stabilize front to back, side to side, and up and down. So if we can kind of consider all those movements as we start to do this lift, we should be in a good spot. The other thing that we talk a lot about, and Jeff Acola had done a webinar, if you guys haven't checked it out, with Paratech prior to, in terms of heavy vehicle stabilization and rescue, the 5-step process that Billy Leach, emphasized for so many years. We now, with the Paratech, the HFSs, we have the ability to essentially effectively lift this vehicle and extricate that patient as needed. So when I talk 5-step, first we get in there, we figure out what the load is, what we're dealing with, hazards, all that stuff. Once we do that, we need to consider these weights because we're putting application of tools into components of our system. So when we start putting components in the system, we need to know the forces that are being exerted to make sure we're setting our equipment up for success. So once we determine what the weight is that we're dealing with and how we want to extricate, initially do that. The next step is we're going to stop that crush. We're going to stop the movement of the larger vehicle onto that smaller vehicle. And this can be applied, this 5-step can be applied, whether it's to heavy vehicle rescue operation or whether it's to an object, a concrete slab that falls on a worker while they're, or even in a trench where a pipe falls onto a worker and now they're pinned between the ground and the pipe. And we have to facilitate a lift that way. So this 5-step is very versatile along with, utilizing the equipment. But first step, again, just kind of to refocus back, what we want to do is figure out what we're dealing with and how much the load is, what other hazards are kind of a concern in this scenario. The next step is stopping that crush. Once we stop that crush, and what I typically like to do is I like to stop the crush with the HFSs that we're going to be lifting with. So in this case, now I'm putting my HFSs where I know I want to do the lift, and we can figure out where we're going to put our capture struts around that. But in my personal opinion, I think the HFSs, when we're doing the lift, should get the priority, so we know that they're in a good spot. Once we do that, we stop the crush. The next thing we need to do is lower that smaller vehicle. So when we talk about with the ratchet straps and the toe keys, lowering that smaller vehicle takes 2 forms. We want to compress that suspension down all the way, and we want to make sure the air is out of the tire. First, the suspension, ratchet strap. In this case, it may be difficult to get that ratchet strap from tire on the front axle, from tire to tire on either side. So you may have to wrap that ratchet strap from the tire up to the A post or another component of the vehicle on the side that you're securing to make sure you compress that suspension as much as possible. You also want to make sure you do suspension on the front and the back side of the vehicle. So that's where having multiple ratchet straps in this case are super beneficial. Once that suspension is captured, the next thing you should do is lower that air tire. So that's just going to bring it down even further. In this point, you may get to a point where you don't even need to lift. So we've stopped the crush. We've lowered the smaller vehicle. That may be enough to get us daylight to move that vehicle out of there. If not, now we go into our lift. So before you do the lift, we make sure the HFSs are in play for our lifting components, and we make sure that we have capture struts set up with that VSK, if you guys have the VSK, to capture as we go. Just in case we need to do resets, or again, if something happens with that HFS, we have those capture struts in play to make sure we can rock on. Now, if you're utilizing your struts, this is where, and you can't put those into play with the capture, this is where the cribbing and stuff can be beneficial. The downside with the cribbing is you have to build up, long towers to make sure that we capture. But again, it's another option, and it's not a bad option at all. Once we've captured, we've done our lift to get that daylight of separation between the heavier vehicle and the smaller vehicle, or the passenger vehicle. Then we can remove that smaller vehicle and do the extrication as needed. So again, with this heavy vehicle extrication kit, I mean, the versatility in it to do what you need to do is huge. There's a lot of options with it, and we're going to talk about a few more here in a second. So again, when we're talking the HFSs, we know that just based off the Paratech literature, they can handle 10 ton or 20,000 pounds, depending on how you want to look at it. So why is this important? Well, we need to know that our equipment can handle the load that we're putting it under. So we want to make sure that our tool usage is matching the load that we're putting on it. So the benefit with the 2 HFSs, if we tie both of those into the system, is now we essentially have 40,000 pounds that we can lift, or 20 tons, depending on how you want to look at it. Just an offset. I'm not going to go too much into determining vehicle weight and the classes of vehicles that exist. But just know you have up to 80,000 pounds unless it's special permitted to go down the road. And a lot of that has to do with what the roads can handle, the bridge weight, and things of that nature. So if you're looking, your common school bus, Every vehicle is rated for a gross weight, an empty vehicle weight, all those things. So when they build these, you could essentially walk up to this bus and say, okay, well, I got a single axle in the back and I got dual tires on the rear axle. So for me, from my size up, if I'm dealing with this, I'm always going to estimate on the high end of trying to figure out the weight of the vehicle. So if I'm looking at this, I know that front steer axle that can take about 12,000 pounds. And then the back axle with the duals on either side, the single axle in the back, that can be max up to 20,000. So if I add that 20,000 and that 12 together, now I'm looking at about 32,000 pounds max that can be, that this vehicle can hold. Well, we just talked about the HFSs and what they're rated for. That can well handle that load. So I know we're in a good spot. Now, there's other things that we need to think about in terms of center of gravity, and we won't spend too much time into that. But just thinking about what these vehicle weights are going down the road, we can start thinking about how we're going to apply that. The other thing, if we're looking at the tractor trailer gross weight on the bottom, like I said, 80,000 pounds is your standard unless you get a special permit or unless an individual state has legislation that says that you can have up to whatever your weight is. When I'm looking at this, the number 5 and the number 4 axle, so we'll just work from the back towards the front. The number 5 and the number 4 axle, again, these ones, what they're going to cut it down to is 17 and 17. So we're looking at 34,000 with those dual axles in the back, 34,000 with number 2, or 34,000 with number 2 and number 3, and then 12 in the front with the steer axle. So you're essentially looking at that 80,000 pounds there. Again, some other ways that you can determine that, talk to the driver. Typically, the driver of the heavy vehicle, they may not have anything going on unless it was a medical emergency. So you can talk to them and figure out, how much load is in there, what they're carrying, all that stuff. So we can talk to them and get a game plan to see, hey, what are we actually dealing with this vehicle? The other thing you can look at is the tires themselves. If you get close enough, the tires will give you a max, whether it's a single or a dual tire on that axle. It'll give you a max weight that it can hold. So that can be utilized for the calculation of the weight. Another thing that you can look at is sometimes with these vehicles going down the road, they actually have it stamped on there what their empty vehicle weight is, what their gross vehicle weight is, and things of that nature. So there's a lot of things that you can look at. One thing that you can pull out to kind of gauge, especially if you're dealing with, say somebody dropped a dump truck dropped a dumpster down on somebody when they dumped it into the truck and they were putting it back down. They didn't see somebody standing there. Boom, it drops on somebody. Super hypothetical situation, but just to kind of get our imagination juices flowing. You can take your phone out and quickly determine, well, what is the weight that this thing may be, or what it may hold. So phones, having Google, those are huge resources for us to calculate whether you want to pull up hazardous material stuff, or you want to, look at a specific manufacturer with, buses, some of these mega buses that are going down the road, having, dual stacks for people and everything. There's a lot of factors here. The other thing I want to touch on with this is we're never truly, unless we lift that vehicle entirely off the ground, which we're not going to do, and I'll explain here why in a second. But unless we're typically not going to reach the point where we're dealing with maximal loads on these vehicles. At most, we're going to deal with half. So what our application is we want to make sure that we're pivoting that vehicle when we're doing the lift. If we're pivoting that vehicle, we're automatically cutting that load in half, and then we can determine calculations from there. So for example, if I'm dealing with a load that's 15 degrees off the ground, I'm dealing with, and we'll just say for an easy number, we're dealing with the tractor trailer on the bottom. So we're thinking 80,000 pounds. It's max loaded, just came off the lot, fully loaded. This bad boy's ready to make some deliveries. So if we take that tractor trailer and we're talking about a lift similar to the situation we had in the back with the back underride with the vehicle that underrode underneath that car, now we can take that, and because we're going to be pivoting that trailer to do that lift, I'm automatically going to cut it in half. Half the force is being exerted into the ground. The other half is going to be dealing with the lift. So from that point, if I have an object that's resting at 15 degrees, I'm dealing with 75% of that half. So in this case, if we're dealing with 40,000 pounds, because we automatically cut that 80 in half, because I'm pivoting off of the front end, whether it's off the kingpin or whether, wherever we're pivoting from, if that thing's resting at 15 degrees off the ground, now I know I'm dealing with 30,000 pounds of that 40,000. If we go up to 30 degrees, I'm dealing with half of that half. So I'm dealing with 20,000 pounds of that 40,000. And then if we're up even higher, we're dealing with 25% of that load. So we're continuously cutting down those forces that are being exerted. So 15 is 75%, 30 is 50%, and then 45 is about 25%. And essentially what's happening is that vehicle, more as we go higher and higher, we're dealing more forces being exerted down onto the ground or wherever it's pivoting off of, and less on the equipment. So essentially, as you set your struts up, or you set your HFSs up, or however you're going to do your lift, the higher that vehicle goes, the less stable it gets, because now we're dealing with center of gravity and shifting. But the higher it goes, the less forces we're exerting down on our equipment. So you can really manipulate this equipment if you understand the physics that are designed or the physics that are adapted to the equipment. You can really figure out where you're putting your equipment to make sure that it's set up for success. And this is why. I think when I actually took a class with, I don't know if Nigel remembers this, but I was down in Southeast Extrication School, and I sat in on the Paratech class, and they handed out this slide in one of their presentations. And the thing I thought when I saw this, I was like, man, this is, I'm just thinking and this is early on in my vehicle rescue days, but you're telling me that there's other forces that are being exerted onto this strut that I've never even considered. So when we're setting these things up, especially if we're setting them up at an angle, and like based off the literature, stabilization, you can go from 45 to 60 degrees, right? And then, if we're doing a lift, we're going anywhere from 60 to 80, maybe sometimes even perpendicular, straight up and down. So just be mindful as you start putting these angles of the strut or the HFSs, or you start putting the HFSs or the strut into an angle, you're putting more axial load onto the strut, and you're putting more horizontal forces onto the strut. So for those that do vehicle rescue and rope rescue, it's no different, right? We always talk about narrow is nice with our rope anchors. Same thing here in terms of forces being applied. I'm not saying that you want to set them up straight up and down every time, but just be mindful. You're going to get more. You can get more out of the HFS if you're lifting straight up and down in terms of force capacity. The downside is now you have to worry about movement laterally. So that's where having multiple struts come into play. However, what I like to do is I like to set up those HFSs so they're at a little bit of an angle. So now I'm still going with a little bit of a wider footprint, but I'm also getting as much out of that HFS as I can. And again, if we look down, if you guys take a peek at this slide, and Paratech on their website, they have this paper that you could print out and talk about. Really, really good to talk about around the table in terms of application. But you have axial load forces and you have horizontal forces. So the more of an angle you go on to, the more axial load that strut is taking. Additionally, the more of an angle you go on to, the more horizontal forces that load is taking. Now, with those 12-inch bases that Nigel talked about earlier, they have those dimples on the bottom. Those things, they take a lot of friction in terms of horizontal forces that are being exerted into the ground. The horizontal forces that are on here, we still want to calculate those chain attachments too to make sure that we're setting them up for success. But again, that base itself, that handle that the 12-inch base has, that can withstand 5,000 pounds of force, and there's a safety factor on that as well. But just know that the systems are set up with a decent amount of friction in them, but we still want to make sure those bases are chained together and made sure that they can't move either side. Another thing that we've been toying around with, and for a long time, we thought we got more height traveled keeping that strut straight up and down. We actually found that putting them on an angle, you're going to get more of a lift out of. So for example, and you can easily do this, set it up, it's the Pythagorean theorem, right? So you can set up a squared plus b squared equals c squared. Well, in this case, the c is going to be your strut length. So you can figure out your C length, your B length on the bottom side of the leg, and then A length is your height. So as you start to extend that strut when it's on an angle, you actually, for an inch that goes out of that HFS, you get more than an inch of lift because of that angle setup. So having them where you get, and this is, technical rescue is all give and take. So if I go straight up and down with my struts, I know, or my HFSs, I know I'm getting 20,000 pounds per HFS, right? I know I'm getting that at full capacity because there's, according to my axial load and my horizontal load here, I got nothing horizontally wanting to move that base or that connection on the bottom, and I have whatever load is being exerted on that HFS axially is straight. So if I have 10,000 being exerted on the top of the HFS, it's 10,000 going down that column and being distributed to the ground. So the downside is once you start putting them on an angle, you actually, you may get to a point where you're calculating for 10,000 pounds of force, but you start to increase that axial load the wider that angle gets. So this is one of those things where you have to just be mindful of how those calculations come into play. So what we do is we'll put them at a little bit of an angle, knowing that, if we lift an inch, we're going to get a little bit more than an inch of lift, but we keep them semi close just to make sure. And this is where that 80 degrees for the setup of the lift plays in. We keep them semi close to make sure that, again, we can connect those bases together. We're trying to maximize as much lift as we can. And we're also trying to get as much height as we can out of it. With these HFSs in the lift, though, the one thing I will say is, again, the higher you take an object off the ground, the more unstable it gets. So you just want to lift enough to get that daylight of separation to make sure that you can pull out whether it's a person or pull out an object that you need to pull out. And again, just to reemphasize, we're still capturing as we lift, right? So just be mindful of it and play around with it. We got into multiple conversations about these angles and the setup and the height differences. And we were like, you know what? Let's stop talking about it. Let's go do it. So we did a bunch of whiteboard stuff. We talked about it. We did the math. We're like, man, theoretically you do get more lift out of it, but let's see application wise. So we went out to a dumpster outside and we set it up. So we had 2 struts set up to the dumpster, connected right at the top, bases connected at the bottom with chain, and we did our lift. And I mean, you put them on an angle, you may get 3 inches of play out of that HFS, but you're getting maybe somewhere 3.5, 4 inches of lift off that object. So, it just, again, it comes down to whether you're dealing with a heavier load and you need to perpendicularly put it straight up and down, and need to maximize how much capacity you can get out of it, or whether you want to maximize your height. You're dealing with a relatively lighter load that it can handle, and you want to, maximize that height and also, maintain that lateral stability. So those are big considerations to think of. The really, really cool thing about these kits, again, is you can put them in multiple situations. So you have a car that drives into the side of a trailer. In this scenario, like I said earlier, if that car is coming in at pretty high speed and it hits that side of the trailer, the sides of the trailer aren't designed to hold that load. So there's a couple things you can do here. Initially, what we want to do is stop that crush around that car. So we stop that crush, straight up and down, like you see on the right-hand side, either strut on either side of that car. Now we can go through our operations of that 5-step we talked about earlier. The other thing you can do here too is, like I said, if the side of that trailer gets damaged, the benefit of that Gold Series or the Gold Series strut is they have that length that maintains the capacity. So if we're dealing with some kind of load shift to where there's a bulge now coming out of that trailer, we can set up similar to a raker setup, set up your struts to hold that into place while we now move that vehicle out after we've done everything we needed to do. Stopping the crush is huge. And again, setting it up like this, I mean, it's an easy way. The thing where Paratech hit the mark with these is these things are rated for a really good amount of weight. So now, instead of me having to build box towers up or box cribbing up to the trailer itself, which could be anywhere from 3 to 4 feet off the ground, I can throw a strut into there, initially stop that crush, and that takes 5 seconds. Whereas before with the cribbing, that could have taken anywhere from 5 to 10 minutes, depending on how sound people were with their cribbing technique. So, even still in this scenario here, there's multiple ways you can lift this trailer. You could put an HFS right next to that capture and lift that way if you just need a little bit of daylight. The downside with what the federal motor vehicle standards are now is they're looking at ways to stop vehicles from being able to drive into the side of these trailers. So they're actually reinforcing curtains that are going underneath the trailer to stop the impact. Where they're running into some issues is there's lobbyists, because again, everything with transporting materials is all about money. So the more, and you think 80,000 is the max. So the more metal components or the more components you have to those commercial vehicles, the less load that it can carry, because we keep adding more things to it. So they're lobbying against these side curtains that are preventing cars from moving in. So now, I mean, but the thing is on the street, there's still trailers that are riding up and down the road. So the chances of a vehicle hitting or going into the side like this is still pretty common. So, stopping the crush of straight perpendicular strut up and down, boom, throw it into place. Now we can start, once we stop that crush, now we can start getting our plan together, facilitate our lift however we want to do it, whether we want to use landing gear, HFSs, the suspension itself, whatever the case may be. And then we can, lower that smaller vehicle and take that vehicle out after we do that lift. So here's a couple scenarios of, and I wanted to kind of highlight, the difference between setting these HFSs up in terms of capturing with the setup. The one thing I love about these HFS 10s is they fit in. It's like the perfect, and I got to give credit to Paratech and the engineers that designed these things, because it's like a perfect setup for getting right into those frame rails. And typically, in most cases, you don't need multiple extensions to make these things fit into play. Now, if you do, the one thing I will say is, and we've run into this a couple times where people do it. If you take that HFS and say you got like 2 inches of daylight in between the frame rail and where you want your HFS to sit between the base and the vehicle itself. Well, sometimes people will crank or pump on that HFS to where it makes contact. Well, the downside is now you're getting rid of that 10 inches of lift that you can, you've cut it down from 10 inches to now 8 inches, because you've taken 2 of those inches up to make contact. So think about your extensions going into this. This is where, the adapter plays in. You can either take that adapter that Nigel talked about earlier, put it in the HFS, and then put a base connection right to it. Or you can take an extension, a 6, a 12, put that into that HFS, and now put that adapter onto that extension within the base on top of that adapter. So very, very versatile. Just you got to get your hands on it and play with it to figure out where those scenarios are set up. On the left-hand side, what you see is we have the HFS is sitting pretty perpendicular. There's a little bit of an angle on it, like I said. But again, those HFSs, you can see they're going to be utilized for a lift. We have chain and the binders down there to attach those bases together, essentially making sure that horizontal play is pretty stout. And then in front of the HFSs on that left-hand side picture, we have the Gray Series struts for our capture. And like I said, I'll talk about whether we want to lift from the bottom or we want to go to the outside of the vehicle. There's pros and cons to each. We found that we like to keep it, relatively low because we're maximizing that capacity of those pieces of equipment. Axles, when you're doing heavy vehicle lifting, axles are going to be your best bet every time. And those contour bases, the multi-bases are good, but the contour bases, there's so much surface contact and bite with those things that they marry up perfectly to those channels that are running back and forth. So when we go to lift, we really want to make sure we're looking to make sure we're lift off of and we're capturing off of a pretty substantial piece of that vehicle. But with the Gray Series in the front, again, keeping them low with the VSK tied into it. And everything's connected into those frame rails, ready to rock on to do our lift. So as we do our lift with the HFS, we have the VSK capturing up, and then we're just locking the collars on both sets of whether it's the strut or the HFS. On the right-hand side, you can see, and this is, it really just comes down to preference. Like I said, we have a tendency to lift low and capture low, but you can also see that we have tiebacks on either side. So when we talk about those 6 potentials for movement, the front to back is stopped with the cribbing on the back axle, as you can see on the bottom left of that right side picture. The up and down is with the struts and the HFS. So we're going to control, initially we stop the crush. We're going to control that up and down with the HFS, and we're going to lift that vehicle off of the commercial vehicle off the passenger vehicle. The other thing that you really need to be and be super, I can't stress this enough, would be incredibly mindful of is that left to right or that lateral movement. The issue that people run into with these, and I think what we have a tendency to overlook sometimes is as you start to separate that larger vehicle from the smaller vehicle, you're taking away surface contact, which is essentially taking away friction. And I've done it myself to where I think a vehicle is going to move one way and it winds up shifting the other. And thankfully we've had tiebacks into place. So when we stop the crush, we lock out our suspension components on the smaller vehicle. We lock out any moving parts. So in this case, when we go to do the lift, because that front axle, that steering axle of that commercial vehicle is impinged on that car, as we start to lift that heavier vehicle, that axle is going to want to play out. So that needs to be stabilized as well. The other thing we have into play here, we're using ratchet straps in this picture, but you can use, whether you want to use ratchet strap, whether you want to use grip pullers or grip hoists, whatever the case may be. I have a tendency or a preference to use grip pullers because I can let slack in and out as needed. But again, that tieback's not taking a ton of load. It's just there to stabilize the vehicle from wanting to move one way or the other. So as you start to do that lift, you take away that surface contact, which is taking away that friction. That vehicle may want to shift one way or the other. You have to be incredibly mindful of the tiebacks on either side. But getting back to the HFSs and the struts there, you can see those are set at a little bit of a different angle. They have more of an angle to it. The way we calculated that out, we were comfortable going with the angle, and here we were looking for that height. So there's a lot of factors that play into doing this lift in terms of like figuring out, trying to determine where center of gravity is depending on where load shifted. In this case, you have two options here. I don't like setting up my HFSs or my capture on anything that has potential to move unless I secure that into play. So like say this garbage truck, for example, that box I know is because I did the scenario, but that box is secured to the frame rails of that commercial vehicle. So if you wanted to, this would be a scenario where you could take a 304 strut, the Gold Series in, and you can connect it to the box itself if you wanted to stay to the outside. Or if you wanted to, do your HFS, your lift from the outside, that's potential to do as well. You just need to make sure whatever that HFS or that capture strut is being attached to, it's of something of structural stability. It has structural stability. If it's a moving part, so say it's a dump truck that can, obviously dump the load off. The one way that you could stabilize that is just to make sure that dump truck, you're not relying on the hydraulic system in play to keep that in place. You're actually chaining that. And this is where those 20-foot chains and the binders come into play again in these scenarios. Chain that dump truck around to those frame rails, make sure that thing is stout and secure. And then you can put your struts or your HFSs onto that box that could move in the back. But, look at those, a lot of these vehicles going up and down the road, depending on where you're at in the country, like the Northeast or even, where I'm at, in Northern Virginia, we deal with some snow. So with that snow comes corrosion of vehicles because of the salt and stuff that accumulates on the road during the winter season. So the one thing you don't want to do is put your HFSs or your capture strut into a component of a vehicle that is rusted out or could punch through, because again, they're dealing with a lot of forces. So there's a lot of factors that play into this. The frame rail, because it's so stout, it just seems to be the best case every time because it's providing rigid structure throughout the whole component of that vehicle. So, a lot of factors here. There's not a right or a wrong. There's always going to be preferences. Biggest thing is just to get your hands on this stuff and look to where it could be applied. And even come up with different ideologies. I always say there's never necessarily I'm never going to do this or there's a wrong way. Each scenario, depending on what happens with the accident, each scenario is going to dictate different placements. So having multiple ideas for placements is going to, it's going to be key. There's always preferences, but the scenario or the call you run is what's going to dictate placement. Again, here we have when we talk about that throw for the Gold Series strut, the Gold Series, like Nigel said earlier, the Gray Series and the Gold Series have a different rating range. So the Gray Series, when you're looking at the capacities on it, that thing's rated to, with a 4-to-1 safety factor, is rated to 20,000 pounds up to 4 feet. So, all right, cool. Like, and the reason that is that the diameter of that strut is a little bit smaller than the Gold Series strut. So we're dealing with a 3-inch diameter with the Gray Series as opposed to a 3.5-inch diameter with the Gold Series. So the Gold Series, because it's able to maintain that, with the 4-to-1 to 20,000 pounds up to 8 feet, you have a little bit longer of a throw to put that Gold Series to, and it maintains that rating. So the picture on the left-hand side, what we actually have set up here, and again, the airbags aren't in the heavy vehicle extrication kit, but I'm sure Paratech would. If you're buying a Paratech kit, you're probably buying the airbags. Their airbags are everything that they make is of really high quality. So when we're dealing with these, you can see the way that we have set this up here is we actually daisy chain the bags together to do the lift. So, and this is where, when we talk about, are we doing a lift between the airbags? Or are we doing a lift between the HFSs? Like, how do you determine? Well, the airbag, I know I can throw that into, I need about 1 inch clearance to throw that airbag into play. So if I'm dealing with limited clearance, airbags going in, but I'm still going to utilize my struts to capture. So what we have here is we have airbags daisy chained together using Ys and the systems that's set up with the airbag kit to do that lift, making sure that they're the right size to make sure we're doing we're calculating for those lifts, and we're getting good surface contact with those bags. And then additionally, we have the larger Gray or the Gold Series struts here to capture with the VSK hooked up to the Gold Series strut. So that chain is actually running from a foundry hook connected in the window on the underside of the car up into a base on the top side of that Gold Series strut. That's capturing it as we do the lift. And then if you get to a point where, you're maxing out those airbags and you have more daylight there, well, at that point, like I may not even keep relying on the airbag. I may go back to the HFS. Or the the HFS. So, I mean, it really comes down to clearance, what daylight you have and the application, but these tools again are very versatile. On the right-hand side, and this is all I want to highlight. A lot of companies are teaching to do a longer strut extension to buses like this, like you see here with the Gold Series. Now, what I will say is it's not wrong. So what you need to calculate for it, and just think, the other thing that Paratech sells is the bipod, right? So this is essentially no different than the bipod. The downside is if you don't account for that lateral stability, as soon as you lift that bus off of that passenger car, and because it's suspended, it's going to want to find its center of gravity. Well, is the motor in the front? Is the motor in the back? Or is load shifted in the object you're lifting? So you just have to be very mindful. If you're going to do a high capture like that, you have to be very mindful of the component you're capturing into. So sometimes, if you're dealing with a heavier load and you go for a high capture like that, that material may actually crumple a little bit as you go to do your lift, and as a rescuer, are you comfortable dealing with or accounting for that in the lift, right? I want to make sure I'm going on to something stout. Sometimes you don't have the clearance to go onto something stout. So, just be mindful of that when you're setting these up. And again, you can see it. You can kind of see it with the chain there, but we're still accounting for that lateral stability because we know that the load as we go to lift, depending on the terrain and the angle of that terrain, it's going to want to rock. So we still want to make sure that front to back, side to side, and up and down is being accounted for during that lift and capture. In this scenario on the right hand side, the lift was done on the frame rails. So you can see the pump of the HFS on the bottom side of the picture. And then the capture was set with the Gold Series on the window frame itself. It's not a wrong thing. Just be mindful of everything that can kind of happen. The selling point is always, people don't want to necessarily get underneath the vehicles because they're worried about the movement of the vehicle. Well, if everything, like I said, if you roll up into this thing and it looks like it wants to move either way, side to side, well, maybe that's your first thing that's stabilized, right? So you stop it from wanting to move, make it safe for people to get underneath. So now we get front to back, we stop that crush, we know our side to side's good, and now we can put our, our gray series low into this scenario to make sure that we're capturing low on that frame rail along with lifting low on that frame rail. Sometimes, especially with a bus like this, and what people sometimes overlook is there's just small clips holding that bus body to the frame rail. So if that was damaged or that rusted out, or for whatever reason in the accident, those became unclipped, and you go to capture with the body of that bus, with that Gold Series, and you didn't account for that, and now all of a sudden you do your lift and something happens with the lift and the HFS, God forbid something happens there, something's not calculated or figured out, and you're relying on those gold, the Gold Series with those larger throw on the top of that bus, there's potential, right, for that separation. So, there's a lot of factors that play into it. Not necessarily saying one way is better. Like I said, I have a preference, but if you're putting something into play, just know the dynamics that exist with that. So those are some things. And again, in this scenario, the Gold Series, we have the VSK hooked up because you're not going to. The VSK just makes life so much easier. The other thing that you can kind of notice is the collar on the bottom side of that strut is towards the bottom side of the base, towards the ground. So instead of somebody having, I'm only 5'10", so it's not like I'm reaching up trying to lock that thing off without a ladder. It's not happening. But keeping it low, like Nigel said, you can invert these things, keep it low, and now as that strut extends with that VSK, because we're lifting, you can lock that collar off from the bottom side, and you're good to rock on. So the orientation of the strut is the capture strut is a big thing too. Here we're talking, and because I talked about tiebacks, I decided I wanted to throw this into play. On the left-hand side, you can see the pickets. You get 4 pickets with the kit that Paratech is selling. I'm sure they would allow you to buy more. We run with 6. So the way that FEMA has rated their pickets, and I won't go into degrees and everything, but a single picket 700 pounds. A picket tied back into another picket is 1,400 pounds. When we do a 1-to-1-to-1 in those configuration, we're looking at about 1,800 pounds, and a 2-to-1 rated at 2,000 pounds. So, think about what the application and the tieback. Like I said earlier, the tieback's not taking a ton of force. So we're not dealing with a ton of load. We're just essentially preventing that from wanting to move one side or the other. So when you set these up, you could potentially get away with doing one picket into, depending on the load of that object that you're stabilizing, or you may want to do a 1-to-1 on either side and make sure that, it's a pretty stout connection into that ground. The other thing that, look for things around you that have, pretty substantial weight to it. So like I said earlier, guardrails, trees, whatever the case may be, make sure that you make your connections. And the only thing on the right-hand side that, I'm showing there is the fact that there's other things around that if you need to do tiebacks, you can make it happen. And in there you see a grip puller, awesome piece of equipment that we utilize a lot in our classes, along with some synthetic round sling to make that. The one thing I will say about the chain and the synthetic round sling, if you're using the chain or the synthetic round sling for anchors, chain not so much. You want to worry about your DD ratio, which Josh Thompson did a really good presentation on chain and bridles and winches and stuff through Paratech. But with the synthetic, you really want to make sure that you're being mindful of those edge protection. That outer sheath of that round sling isn't designed for edge protection. It's designed to to protect the interior of the sling with the rate, but it's a component of that sling. So it shouldn't just be left without edge protection. You still want to make sure that's protected. And you can see we just have some floor mats that we found in the vehicle to attach it onto the blocks there.
All right, thank you, Andrew. We're going to stop now for 5-10 minutes. We're going to have a question and answer segment for you guys to actually give us some questions, what you've seen so far, or whatever you think of. Then we've got this segment of question and answers, and we'll have another one later on in the workshop. Okay, here we go with some questions. We got some questions coming up in the chat. I'll take a look at the questions that's there. Let me just take a look at this. Where were we? One of the questions we had is, will this training be recorded for later viewing by chance? Yes, it will. It'll be at www.paratech.com/workshops. It'll be in the same place as the rest of the webinars that we've done previously. So it will be up there. The answer is yes. Another question we've had is, let me take a look. This one's for you, Andrew. Is the horizontal load calculated from the vertical load or from the final axial load figure?
So when we're looking at the horizontal and the axial load, we're taking whatever weight we determine we're lifting, considering the weight of the commercial vehicle and also the weight at the angle that it's at. We're going to take that load and split that into two between the two struts or the two HFSs. And at that point, now we're considering the weight of the vehicle in determining the horizontal load and the axial load. So within that system, right? So just say hypothetically, we're lifting 20,000 pounds, and depending on what strut angle and the load calculations, depending on what strut angle we're at, that will give us a rough estimate on our axial load and horizontal load. And what we do in a lot of our classes is I don't believe I had added any pictures of this, but we have weight scales that we put on there. And again, that horizontal load we wind up using grade 100 chain in most cases. So we get that 8,800, working load limit with the safety factors that exist with the chain. Well, that horizontal load is also, part of that horizontal load is being absorbed by the chain, holding them together. And then the other part is absorbed by the friction, the dimples on the bottom of the Paratech base, the 12-inch hinged base. So again, all that stuff changes depending on angles and load calculation. But again, the cool thing about that, and try it out. That'd be my recommendation. If you have HFSs with calculate what you think your load might be, see what the pressure is reading out on that on the gauge on the pump itself, and then you can see depending on and it's telling, like if load shifted and one side is receiving more pressure than the other, it could be due to angles, it could be due to pump speed between the different operators. It could be a bunch of things. So long story short, the answer to that question, how to determine your horizontal and your axial load, is depending on what angle your strut's at. That should give you a multiplication factor. That multiplication factor is determined off of the load calculation that you come up in the first step of that process.
Thanks, Andrew. Another question we had is, will there be any multi-chain bases added to this kit? Well, we're already looking into that. Every time we come up with a new base, we take a look at the kits, and we basically we have a round table with our RSMs and our management. We'll take a look about adding and taking things away as we see fit, and basically as it becomes a better use for the product line that's out there for what you need to handle with the different heads and bases. So the answer is with that is we are looking into it, and there may be multi-chain bases added to the kits. Just keep an update, but you can still purchase them separately. It just gives you another couple of bases in your arsenal for different heavy vehicles. Another question is there data on the working load limit of the multi-base in the different configurations, particularly as a chain grab? Well, when we make our bases and our heads and different things, we try to test them to the capacity of the strut. You got a working load limit of 20,000 pound, but with a 4-to-1 safety, 1-to-1, you get 80,000. All our bases are normally tested to the 80,000 pound compression. With the chain slot that's in the multi-base, that chain slot, we took a look at the highest grade 3/8 chain, which is the 120. take a look at the safety factor of the 120, which is 5-1, puts it up in the 50s, 50,000 marks. And I know that slot easily goes over that capacity. Those figures are all in-house with engineering. We don't just make the base that'll handle the working load limit. We make the bases so it'll handle the total of the strut itself. With bases like that, though, because it's got the open end, it's a little bit hard to get it up to 80,000 pound with continuing the 2.5 or 3 inch diameter on the head. So, but we do strive to do that. I hope that answers your question. Another question is just as an academic question, trying to budget for different heads, especially that was the same question. Sorry. Andrew, this one's for you. With the high capture, does the 45 to 55 degree angle help negate the need for lateral tiebacks?
I would say it could, depending on where your center of gravity is. But typically, I mean, and you think about it, right? Like, and I alluded to this earlier on the presentation slide. When my angles are up, and no different than using the bipod, right? When you lift, let's just say you're lifting with, you're lifting a concrete slab off the ground. You got your bipod situated right. There's going to be lateral forces that swing at the bottom. So when I talked about the tiebacks are preventing that, or we're setting them up to prevent that lateral swing. Once that friction is taken up, it still is going to want to, or potentially depending on the angle, the load shift, how the lift was done. There's a lot of factors into play. So to kind of take out that variable that exists, right? Because we want to stabilize or control movement in 6 different directions. The lateral tiebacks are still going to be needed when you capture high. And it's only, I mean, you could play around with it. And there's other factors that come into play. If you're moving a lot of parts around that object, especially, pulling a car out or doing whatever, there's things that come into play that we want to make sure those six components or 6 movement types are controlled as much as we can. So yes, it could potentially help in a static situation, in a dynamic situation where we're lifting, moving, doing all these different configurations with the setup, and it's dynamic. I would not trust just having the lateral stability with the strut at that 45 to 55 degree angle. I would still want to do some kind of tieback low to make sure as we take friction away between the car and the object that we're lifting, it's not going to want to move. And I mean, even you can even look at it. Say you don't need a heavy vehicle to set this up, right? Say you set up a vehicle on its side, and I did it with
per turn on the strut drivers. I think I'll answer that one. Basically, with that, we don't really know at this time because we have not basically tested that for one single turn of the ratchet to how high it's going to lift. That I can get back to you. We can run it's an easy test to run on that, but I think it's around about maybe an inch per turn. But again, I'm not sure. I will definitely get back to you on that one. That was from Thomas Minnick. Thomas, if you go on the Paratech website and actually put that question in, you should get an answer hopefully next week on that. So we should be good. What's another one? We had one question here that just came in. This one could be for you, Andrew. The picture of the bus on its side, is the 4x4 on the end of the strut to displace load or to stop the base from penetrating the roof of the bus?
Yeah, so that 4x4 is there to help with not penetrating through the sheet metal that exists on the bus. So it's just distributing that surface area a little bit better. So we know there's positive capture between the base head and the bus itself.
Okay, we got one question here from Nathan Zeck. Is Paratech still offering the buyback program, helping companies switch from the other strut brands to Paratech? Nathan, absolutely. If you contact Paratech's customer service, they'll put you in contact with your RSM, your regional manager, and he can definitely help you out with that. So, okay, now we're going to go back to the PowerPoint. I'm going to take my headphones off, and we'll see you there. Okay, coming back. The other thing that's in the kit is the single-piece forge hooligan tool. It's got a curved adze with a point and the thin, slim fork at the other end, 30 inches long. It's electroless nickel-plated. All you guys out there know it as the Halligan tool. Great little tool. It's normally the first thing off the truck or the engine with an X as a set of irons. So it's good for prying. It's good for putting position holds in your vehicles on the sheet metal for your points on your multi-base. And the fork is there so you can actually go in and open up the door a little ways with as well as the adze end, so you can get your spreaders or cutters in. Hydrofusion strut kits. In this HV heavy vehicle extrication kit, comes with 2 Hydrofusion 10 kits. Hydrofusion 10 has got a lift capacity of 10 US tons, 9 metric tons. Comes with a 2-to-1 safety factor on the lifting device. So the actual ram inside has got a 2-to-1 safety factor. When you do your lift and you spin your gold collar down to make contact with the tube, then it goes back to a strut, which is now a 20,000 pound with a 4-to-1 safety factor. But once you start extending that strut and that collar does not make contact with the tube anymore, it drops back to the 2-to-1 of the ram that's inside there. The Acme thread strut and the Longshores fit inside the top of the Hydrofusion. There's a silver ring in there that compresses down when the Longshores go in. It stays up when the Acme thread struts are used. We got 3 different sizes. In this kit, we got the 10-inch. We've also got a 4-inch and a 16-inch. 4-inch is normally used more on your light rail, which needs a very, very small insertion to do the lift. On your pump, this is on all Hydrofusions. If you take a look at the gauge, if that needle's pointing towards, that's showing up around about maybe 2800 PSI. So if you double that capacity, that PSI, 28, that actually gives you a 56,000 pound of lift on that, 5,600 pound of lift on that Hydrofusion, sorry. Again, my thousands and my hundreds mixed up. So basically, you're going to double that figure to give you the lift. Is it 5,000 pound? On a 2-to-1 with a 10,000 PSI 2-stage pump, it's going to give you a 10,000 pound lift. Hoses, we used to be able to disconnect them. We don't disconnect them anymore. And that's because of they get dirty. And if dirt gets in them, they tend to seize up and leak a little bit. So we don't do hoses that are not attached anymore. However, we do extensions for these, for the hoses. We can't put an extension on the hose if we need to get further away from the load. We need proper placement, as Andrew said earlier, with the Hydrofusion to maximize the lift and maximize your pressure on that Hydrofusion to achieve the lift you need with a heavy vehicle or a light vehicle. It could be a concrete block, whatever, as long as you rig it right, you can lift with it. Okay, Andrew, back to you on your application.
So these, like Nigel talked about earlier, the HFS 10 or the HFSs in general, the thing I like about it is the versatility, how it fits into lifting objects. But also that gauge readout is huge. So if I set up like some of the lifts that I showed earlier, or Nigel slid to earlier, if I'm looking as the OIC and I'm making sure that, you know, our operation is going smooth, hopefully, if, you know, everything's rigged right, you know, those numbers should be pretty close. So when I look in that gauge and it says 2,500 on one and maybe 2,700 on the other, like we're doing pretty good. Now, what's going to change that is angles, load shifting, and things that I may be out of control of. But what I like, though, is the fact that if I'm looking at that gauge, now I can kind of see, you know, all right, did we calculate for this right? And what are we, you know, truly putting forces on? If we're pumping on that thing and the gauges on both sides, we're doing, you know, obviously using 2 HFSs and we're lifting off the frame rails and that thing's pumping up towards that 10,000 mark on either side. Well, again, this is where that 20,000 pounds comes from. I got 2 inches of square, 2 square inches of contact on that base head, which is applying that 10,000 pounds of force to that surface area. So now I get 20,000 pounds of lift. Well, if I got 10,000 on one gauge and 10,000 on the other, there's something going on here or I didn't calculate right. So, you know, we really want to be mindful, and there might be cases where you do that. And we've done it with, military, trucks going up, in one of our classes. We had to put the strut, straight up and down to maximize how much capacity we can get out of it. But we definitely, pushed it towards that 10,000 mark on either pump. But the gauges, man, the gauges, they do so much for us in terms of, making sure that we calculate it right, and also making sure that we have, we're being mindful of the loads that we're dealing with. The benefit of that 10 foot line on there is I really want to set those pumps up to where we're away from the load in case something does happen, but also that each pump operator can see each other. So if one person's pumping away and they're going, really fast and the other one's kind of taking it nice and slow, well, we're going to start to see this in the lift as opposed to this in the lift. So being close enough to where they can see each other, they're watching each other. They're also away from that lift. That's key. But what you see here is we put it, the HFSs, like I was talking about earlier, when the airbags, when there's limited access to get a lift, the airbags are good. When you have access like this, to where there's an object in between a larger object and we need to do a lift and we can get that HFS into play, you can see the HFS here. We've done a lot of studies in terms of matching up that the gauges are pretty spot on. So we have scales that we'll put on the bottom of our 12-inch hinge bases to see what forces are being exerted down that strut. And I mean, and I'm not saying we're going to do this on the street, right? Like I'm not going to come up with a protractor and figure out what angle my strut's at and figure out exactly what load's at. That's for us in terms of training to determine when we're messing around with things out back safely. But what we do, what we show here in a lot of our classes is we want to, that chart that Paratech puts out is factual. Also the pump, that pump readout, we'll get, if I got 2,500 on that gauge, it should show me 5,000 on that pad there because that's what it's taken total in terms of force. And then obviously depending on that angle and everything, it might be a little bit more. But I'm looking at that thing and then the numbers are spot on. So the science and everything, like I said, the physics and everything that are behind all these principles and the application is key. The HFSs were used in this scenario just because we had a little bit more daylight and they're easier. It's easier for me to throw a couple HFSs in, a couple capture struts and rock on with what I need to do. Now, because we're going up a little bit higher, you can see that this is another scenario where those Gold Series struts come into play. Longer span with a higher rating of that longer span, it just makes life a little bit easier for us. But multiple applications to do the lift and those numbers jive. You understand the gauge and the readout and what you're lifting, you should be pretty good.
Okay. Now I'm going to talk a little bit about the multi-force. Basically, kit, it's a single inflation two-chamber bag. It's got a 31 ton or 28 metric ton maximum capacity lift. The maximum height on that bag is 20 inches. Maximum pressure, inflation pressure on the multi-force is 150 psi. It's got a composite base with sliders. If you take a look at the picture on the left, you'll see the little yellow sliders that's on the bottom of that black composite base. It's got built-in relief valves on the top and the bottom of the bag. So if anything happens with load shift on this multi-force, the multi-force will relieve itself as well as the controller. So it's less likely to be damaged. It's got a yellow X on the top. So again, that's for ease of placement. Basically like our Maxi-Force bags, the center of the X marks the spot. And the remote placement kit comes with its own controller, regulator, hoses in a little pack saddlebag that you see on the bottom right. So the handle will extend out to around about 50 inches. It allows you to slide under a vehicle. So if you take a look at the front of a semi, the axle on the front of a semi is approximately 5 feet away from the front of the bumper. So if any of you have done a lift on the front of a semi using the conventional airbag, you know that you're going to crawl under, lay down some cribbing, place the bags, whether it be one or two, ready to do the lift. But what this thing does, you can slide it under in place, do the lift, it'll come up, make contact, and at about 75 psi on the front of that 12,000 pound, it'll take it up around about 18 to 20 inches. It's a great little tool. As you see the picture on the left-hand side, it comes with optional flashlights where the lights will point up when you slide it under. So it pinpoints the axle where it needs to be. So your 31 ton on this is approximately up about 6 inches. At max height, you're going to lift around about 5 tons at max height. So it does drop off a little bit. We have got a curve in the manual that tells you the drop off with different heights of the multi-force. What it does also is when you use conventional airbags, when you're using 2 conventional airbags, you lift the bottom first, then you lift the top, makes contact, and you do the lift simultaneously. The multi-force does that on its own. The bottom will come up, make contact, and around about maybe 8, 12 psi, the top starts inflating, then the both compartments will fill together to achieve the lift. It's a very stable bag. When we demo this, we demo it with stabilization and without stabilization. What I mean by that is we lift the car and we shake the car so you can see how stable it is. Then we go back and then we do the lift with stabilization on the bag. Like I said, it is a great tool. The base can be changed if the base gets broke because it is just composite. Can be changed out. The handle can be changed out. Everything can be changed out on this. It is compatible with our Maxi-Force 150 psi airbags we got now with controls and hoses. So it's all compatible through the line. Okay, Andrew, back to you.
So I'll be honest with the viewers. My rig doesn't have multi-force bags on it. So when I was looking at this presentation, I'm like, well, what was an application that we could have used, or could have used it on? What I don't, and again, this goes back to single point lift. What rescuers and myself included, I was fortunate enough to take a level 1 and 2 rigging class to kind of understand dynamics, lifting and slings and center of gravity and stuff like that. But in the heat of the moment, to try to figure all that stuff, I mean, these guys, when you're doing a lift of an object, so say, some skyscraper is being built and they're moving object from here to there. These guys are sitting down, they're calculating everything out. They know exactly where the center of gravity is of that object, and they're moving it to where they need to move it. They've made sure their angles for the sling, or they can take that force, and everything is should be as perfect as possible, because it's no life or death in that case. In our case, though, we get on scene, at 2 o'clock in the morning, you wake up from, dead sleep, or the pager goes off and you run into the firehouse, your heart rate's going at 100 miles an hour. You're already focused in on what's going on to try to, we're talking about controlling in 6 different movements and doing a 5-step process and sizing it up. And, what are we dealing with? Talk to driver, how many patients, how many cars, all this stuff. The other thing to that is, like, if we're doing this lift, we need to know where that center of gravity is. And And there's, we control that center of gravity by rigging in those, preventing those 6 areas of movement, right? Front to back, up to down, side to side. So with the multi-force bag, you have to be incredibly mindful of your application in terms of where you're doing the lift. So you can, you stick that thing in the center, what you think is the center axle, but because of load shift, you go to lift it. If you don't have tiebacks on either side, it could potentially move one way or the other. Or, like you lift off the pumpkin, the transmission housing in the back side, that might be offset a little bit. So you slide that in, you do your lift. And again, what you think is the center, because you looked at it real quick and you're like, oh, I should be good here, and throw it in. And I only say this because, unfortunately, I did it, right? Like, we're in this training site. The one way to learn is to do it. And, you stick a bag in there. You're like, oh yeah, that looks center. Let me stick this bag in there. And then you go to lift it, and all of a sudden it starts going like this. And now it was a training scenario. There was nobody else around. We were just, trying out the equipment. In no way, shape, or form would I ever do a single point lift without having capture, tiebacks, all those other things. So what I do like, though, is, and the picture I have on the right-hand side was an actual, unfortunately, it was a call we ran. The car rolled on them. Somebody was pinned underneath of the front left front axle, and we had to get them out of there. It was a recovery in this situation. So again, incredibly unfortunate, but the maxi force could have been an option here. We wound up using a floor jack because of the height, but man, if that was up a little bit higher, it would have been like, well, all right, so what's next? Airbags, are we talking strut up to that, to that A pillar, or in between the A pillar and B pillar on the roof line? So the big thing, again, looking at this scenario, is make sure that movement, and we did it, we made sure the front to back movement was good. Side to side movement was good. We did a single point lift off of close to that driver's side door on the frame rail. And you can see the floor jacks in play there, but this could have been, access permitted, could have been an easy spot to put that multi-force bag into, inflate it. We're capturing as we go, boom, get it up. Now we can rock on. The other thing we ran things to think about, that unfortunately that person was wedged between the axle, the swing arm of the suspension, and obviously the vehicle itself. So all those moving parts you have to think about in terms of like how, if we do this lift, what else is going to move when I go to do this lift? So there's so many facets of things to think about. But I just, I figured, let me highlight a point where a single point lift would have been good. What I like about this, though, is it's not single point to the point where, there's potential like front to back. If I single point, there's this movement and this movement, right? I have pretty wide base on the backside that I'm pivoting off of between the passenger side back axle and front axle that I'm doing that lift off of, to where I felt comfortable doing that single point lift. Just being like, I can't stress it enough. It's not that it's not an option, but you have to be incredibly mindful, especially the higher you go, because the higher you go, the less stable you get, because you're taking away that surface contact and the friction involved with that. Just be mindful of that front to back, side to side, and up and down. So, just a kind of a street application of where that multi-force bag could have helped, especially if it was, that truck was souped out with some, a pretty good suspension package and lifted off the ground. That floor jack wouldn't have touched that thing. But the multi-force bag could have. So things to think about.
Andrew, do you want me to take this one?
Yes, sir.
Okay, guys, using the multi-force as a sideways application. Excuse me. If you take a look picture on the left-hand side, that was an actual where something happened. I think it was in Philly somewhere. Something happened with the car. They were doing something with the car that actually pinned the woman against the wall. So that was an actual where they could actually put the multi-force in. As you see, they blocked it out. I just did a horizontal push, pushing that car away using the multi-force. What the multi-force does for you, it offers you that 26 inches of spread to push that car away. On the right-hand side, does the same thing. These are with container units, so these are pretty heavy. Again, it did the same thing with pushing it away. But a lot of times with something like this, horizontal push, you're just trying to relieve some pressure so you can extricate. A lot of times with something like this as well, especially in FDNY Training Academy, they use these to push the subway car from the platform. A lot of times people jump on the car on the outside to take the ride. They jump on a non-raised platform. So they going in, then all of a sudden they hit a raised platform. So they tend to roll up the platform with the train. So the question is then, how do we get them out? Can't just lift the train because you're going to destroy basically you're going to cut the person in half. So what they use this, they'll drop it in. And again, because of the 26 inches and because the bottom inflates, the one segment inflates first, they can actually push and tilt the train out of the way so they can get the person out from the actual train tracks. The other thing we use these for, which I've used them for, I did a light rail lift using these. I had one each side of the light rail, stabilized it, and lifted the light rail. It's called light rail, but the car weighs approximately just over 100,000 pounds, so just over 50 ton. So if you take a look at what Andrew was saying earlier about cutting up the segment in the vehicle to give you the load that you're going to lift with the equipment you got. So you were looking at around about maybe about 15 ton because of the cars. The cars were separated in 3 segments. So we were looking at about 15 ton. We did the lift on each side of the car, took it up off of the rail. Oh, wrong way, sorry. So going back to the multi-force, a rocker rail. Rocker rail lift, as Andrew said earlier, in the one, single point is dangerous, especially when you don't know what you're doing with this. As he said, the gravity and the center of gravity of the vehicle. But on a rocker rail lift, because we got that wide spread on the backside with the wheels, you're going to put cribbing up to your rocker panel and do this real well. Also going back to what Andrew said about the heavier vehicles, your school buses, your dump trucks, and some of your semis now. Most of them now, the pumpkin, which is the differential, is offset. So if you think you can put this bag right under that pumpkin and do the lift, then you're actually going to push that heavy vehicle to one side. So you have got to be cognizant of what you were doing with airbags in general. Dot your I's, cross your T's, just so you have a safe lift. And if you take a look at the picture on the bottom left, it shows where the one section is inflated. It's gonna inflate the top section once it gets to the appropriate pressure, and do the lift. Whereas you see on the total right hand side, it actually lifted the car off. This one was done without stabilization, as you see. It was just to show the height you can go to. But we'd never lift without stabilization. We'd only do this as a demo. And that demo, we'll take it back down, then we actually lift with stabilization in place. Okay, we got another question and answer segment. On the previous slides you've seen in this workshop, myself and Andrew will be available to go over your questions and hopefully answer them. Okay, now we're going to go to the question and answer. This is the last question and answer at the end of this webinar. We got a couple more questions that have come in. Let me take a look. I've got one for you, Andrew. If you have a load shift or hydrofusion failure while chasing a lift with a VSK air controller, will the load be captured with just the air, or are you supposed constantly manually spin up the collars, basically?
No. So remember what Nigel said back to earlier. And if you lift an inch, support an inch, right? So in even an inch, when you're talking about like if you had some kind of failure with any lifting equipment and that load moves, there's a pucker factor that exists there. So I would argue that any lift you do, somebody should be manually like capturing that collar. So the answer to that question is anytime that collar moves and there's daylight, capture it. And it, the most you want to go at an inch. But like I said, any little bit of daylight, we want to capture it at almost as soon as that daylight exists between that collar and the HFS itself or the capture strut.
Okay. Nathan, I hope that answered your question. So the answer to that one is no. You've got to constantly capture that collar with a strut. So another one from another Nathan. There's a lot of Nathans on here today. Do you have the dimensions for the HFS pumps? Nathan, if you want to contact paratech.com, go on the website and fill out the request. They will get you the actual dimensions of that pump for you via email. I don't have them with me, but you can get them from paratech.com. I think that wraps up all the questions. Let me just take a quick look. Yes, that wraps up all the questions. So, Andrew, anything else you need to say?
Yeah, so there was a little bit of technical difficulty earlier, and I didn't get to finish what we were talking about with the high capture at the 45 to 55 degree angle of the strut. So what I was getting at before was you can, even without having a larger, like a heavy load to do that with, my guys and I went out yesterday and we wound up doing a same kind of scenario set up with a vehicle on its side. So HFS is on the clean side, dirty side towards the A pillar and lifting it that way. No matter what, when you start to do a lift, especially with a high point, the object you're lifting, because it's going to be hanging off of that high point, it's going to want to shift a little bit. So the way that we get around that with the vehicle yesterday was we, just followed with wedges on either side. The way we do that with larger vehicles is by doing the tieback. So if you do a high capture, a high lift, there's going to be potential for swinging once that friction between either the ground and the object or the larger load in the object, once that friction's away, it's going to want to sway. So that actually rhymes. So that was pretty good. I didn't intentionally mean to do that. But that being said, just account for it, right? So the movement in 6 directions, front, back, side to side, up and down. So that's something we want to be mindful of. Hopefully that answered the question. And to kind of wrap it up, I just want to say thank you to everybody who stayed on a little bit long, but there was a lot of good information to get out there in regards to the heavy vehicle extrication kit and the components. If you guys have any questions, like Nigel said, obviously feel free to reach out to Paratech. Blue Collar's information, if you go to bluecollartn.com, you can submit a form there for people who are interested in further education or training classes. We also are very active online with Blue Collar Training Network on Facebook and Blue Collar TN on Instagram. So we're a big fan of sharing information. Our group is always about trying to find new ideas and very open to being involved in the learning process with the students. And it's not about just saying, hey, this way works every time. It's always about figuring out, different methods to apply with different situations and different scenarios. So the owner, Jeff Acola, really, really squared away guy, put together, and along with our group from Blue Collar, we just want to say thank you guys for participating in this. Please share the information. Reach out to us if you're interested in further education from the 3 avenues I listed earlier. And I just want to say thanks again to Paratech for allowing us to join you guys today and be a part of this learning process. So thank you all. And that's all I got. Go ahead, Nigel.
Okay, thank you, Andrew. I'd like to thank Andrew Hale from Blue Collar for the presentation today. I'd like to thank Jeff Acola, who's the owner of Blue Collar, for allowing this. I'd like to thank all of you guys out there for being on this webinar with us today. It was covered 2 hours. It was long, but it was, as Andrew said, there's a lot of information on there. There's a lot of information out there. I'd like to say from the Paratech family to everybody out there, again, thank you. Have a Merry Christmas and a safe and happy New Year. Be safe out there. Again, thank you. Bye.
The heavy vehicle extrication kit consists of 2 10-inch hydrofusion kits, 2 extension converters, 8 12-inch by 12-inch hinge base with anchor ring, 2 36 to 50-inch Longshore strut, 2 48-inch to 73-inch Longshore strut, 2 72 to 116-inch Longshore strut, 2 6-foot extensions, 2 4-foot extensions, 2 2-foot extensions, 2 25 to 36-inch Acme Rescue strut, 2 24-inch extensions, 2 12-inch extensions, 4 48-inch pickets, cribbing kit, 4 V-bases, 4 contour bases, 6 multi-bases, 1 VSK controller, 6 tie-down keys, 2 20-foot grade 100 chains, 2 ground pads, 10 ratchet straps, 1 SBF hooligan tool, 2 chain binders, and 1 multi-force remote placement kit. We're looking at heavy vehicle versus light vehicle underride. Going to go over what we can do to help the patient out that's in the smaller vehicle with the large vehicle resting on top of the smaller vehicle. First, we're going to stop the crush so the heavy vehicle doesn't sink further into the smaller vehicle. Block out the suspension, block out the truck from rolling any further. Then we're going to start and go in with our stabilization of both vehicles. Once both vehicles are stabilized, we're going to look to lift the heavy vehicle, either extricate in place or remove the smaller vehicle from under the heavy vehicle. Okay, large vehicle versus small vehicle. The procedure we're going to use to stabilize both vehicles and attain a lift. First thing that's going to go in is the stop the crush strut. That's this strut here. It's 36 inches to 50 inches. Second thing that's going to go in is going to be your stabilization strut. Your 72 to 116 is going to attach to your chain, stabilize the tank. Next thing, we're going to stabilize the car with a 25 to 36 extension and the ratchet belt on the car. Then we'll take the ratchet straps, the tie-down keys, and the cribbing so we can tie the suspension down on the car so the car does not rise when we lift the tanker. Then we're going to set up the hydrofusions so we can achieve a lift on the tanker using the 48-inch Longshore and the 10-inch hydrofusion pump base head. After all that's done and we achieve a lift on the tanker, we're going to come over, use the multi-force under the back of the car, and lift the back of the car while stabilizing. Okay, first thing, I'm going to come in on the tank. I'll put the Longshore nearly vertical to stop the crush on the big vehicle over the small one. Then I'll come in with the stabilization of the big vehicle. I'm going to bring in the chain. Take the slack out of the chain. We're going to stake the base. Stake should be driven in 2/3 of the way for demo purposes. I'm just going to take them in about 6 to 8 inches. Make sure my stabilization is tight. Then connect your 2 hoses to your 2 stabilization struts. Connect the hoses to your VSK controller. Be sure to spin down the collar on the vented coupling, otherwise it will leak. Open up your cylinder, let air go to the struts. Open up your controls, just set and forget. Then, going to set up to stabilize the car. First, what I'm going to do is tie the suspension down on the car, attaching the ratchet strap, attach to the top of the wheel, insert your 4x4, take out the slack, and you're going to ratchet the suspension down. What the 4x4 does, it keeps the belt off of the glass. That way the belt will not get cut by broken glass, or if the glass is intact in the back, the belt will not pressurize and break the glass unexpectedly. Now the tank is stabilized, I can come under the tank. Then we'll do the same in the front and tie the suspension down on the car so the car actually stays as low as it can to the ground. I'm going to feed some belt out. I don't need to use the cribbing on this side. Now the car is down. Now we can set up for our lift. I'm going to come in with a hydrofusion. Come in with the head. The hydrofusion, we need it around about 80 degrees. That's where it's actually lifting. Then we need to stake the base. Attach the pump. Make sure the pump is open before you attach. When we do the lift using the hydrofusions, we need to go simultaneously. Line of sight is always the best. You ready? Yep. Okay, let's go. We really need another 2 firemen to work the stabilization. Okay, you're only going to lift as high as you need. Lock all your collars up. Then we're going to set up the vehicle stabilization on the back of this car. The suspension is all tied down. I'm going to come in with the Halligan tool, make the purchase, bend the metal out, then set up for my stabilization. 1 foot extension, strut and base. And bring it into the hole. Ratchet it down to attach the strap. Tighten up the strap. Okay, that's good. Car is stabilized. Then we're going to set up for the multi-force to do the lift on the car. For the person that's trapped, make sure the handle's down. Tighten up your safety collar. Make sure it's on. Connect your hose to your controls. Tighten up your safety collar. Connect your air source. Extend your handle. Slide in place. Make sure your air source is on. And you inflate. Making contact. At this time, we'll need firefighters at each of the stabilization. There, you have it. I'm Nigel Letherby with Paratech. Thank you for watching. I hope it was useful. If you want to see more, please like or subscribe.